Welcome, this is a 12.1 tangent lines, and what we're going to do first, we'll start off with some vocab. So let's have you guys write down this picture and these couple sentences right here. So we're talking about tangent lines, and so a tangent circle is a line in the plane of the circle that intersects the circle in exactly one point. So we have this line, it's not going to actually go through the circle that we have right here, but it's just going to touch the circle at just one point. That point where it touches it is going to be called the point of tangency. Now again, don't get kind of confused right here. We did deal with like the word tangent when we did our like SOHCAHTOA stuff, but this is something a little bit different, so don't get those two things mixed together. So again, a tangent is a line in the plane with a circle that intersects in exactly just one spot. And what that spot is called the point of tangency. And we have a couple theorems right here, a couple of key concepts. So the first one is, it says if a line is a tangent to a circle, then the line is perpendicular. So if I'm looking right here, this line and the radius right here, they're going to be perpendicular to each other. So if it is a tangent and the radius, they are going to be perpendicular, and we know a lot of things about perpendicular right angles that we have right there. Okay. The next one that we have right here is just like the converse that we have right here. So if it tells me that if a line in the plane of the circle is perpendicular to the radius at the end point, then the line is a tangent. So again, remember like we did our converse, we just said flip. So again, if we know that this line and the radius make a 90-degree angle, then we know that the line AB has to be a tangent. So it's just going to be the converse to our first one, right? We had a line, if it is a tangent and the radius is going to create 90 degrees. Next one, just the converse. And then my last one that I have right here says if two tangent segments to a circle share a common endpoint outside of the circle, then the two segments are going to be congruent. So if I look at this, if BA and BC are tangent to the center that we have right there, then AB and BC will be congruent. Okay, so knowing this, let's do a few example problems. Alright, so our first problem that we have right here, it tells me that MN, and let's not give the answers away, let's see what we have right here. We have MN is going to, and ML, sorry, and MN are tangent that we have right there. And we want to know what is the value of x. So again, remember one of our theorems says that if they are both tangent to the same center point, then these two are going to be congruent that we have right here. So again, if I look at this and if I look at the figure OLMN, it's got four different sides. If it has four different sides, then it is going to be a quadrilateral. So again, I'm going to say the sum of a quadrilateral lateral is going to be 360 degrees. So 360, so I have right here, I'm going to have, again, all these angles added together are going to equal 360 degrees. Again, I know that my radii and my tangent right here, they are going to make a 90-degree angle. So if I'm looking at this, I have 90 degrees and 90 degrees, so I have here is going to be 90 and 90, and it told me that this angle right here was a 117, and again, we don't know what that other angle is. That's going to be x right here. So then I add up all these together that I have right here. I get 180 plus 117. It's going to give me 297 plus x, and again I'm going to subtract 297 from both sides, and I get 360 minus 297, and this is going to give me right here, that crosses off, we're going to get x is going to equal 63 degrees. Okay. Alright, we go. Next problem that we have, it says what is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above Earth. Earth's radius is about 4,000 miles. So what we're going to do is first we're going to have our circle that we have right here, and we have my radius. It told me was this right here was 4,000 miles, and we have on a clear day 2 miles above Earth. So let's have, we have here's this right here, which is going to be about 2 miles. And we are trying to find out what the distance is to the horizon. So we're trying to find out this. Whoa. Didn't mean to pan at the last second, made a little dip. Alright, so again, we're trying to draw this tangent line that we have right here. So we have, here's this there we go. There's this tangent line that we're trying to find. So we're trying to find out what is that distance that we have right here. So the thing that we got to remember is that we have with the tangent line that it creates a 90-degree angle. It creates a perpendicular angle right there. It's super important. And we were also told that this is a radius. So this is also going to be the same, which is going to be 4,000. So again, I can see that I have a right triangle. I have 2 or 3 sides of a right triangle. So to find the other side, all I'm going to do is use Pythagorean theorem. So I'm going to have x squared plus 4,000 squared equals, and again, I'm going to add these two together right here, combine those together to get my hypotenuse, which is going to be 4,002 squared. And again, I know that's my hypotenuse because it's across from the 90 degrees. So again, I'm just going to calculate these out and subtract it across. So I would subtract it across, and I'm going to get x squared equals, I'm going to type in my calculators here. I have 4,002 squared minus 4,000 squared, and that's going to give me 16,004. 16,004. And after that, I'm going to square root both sides that I have right here. So I take the square root of 16,004. And this is going to give me approximately, x is going to equal approximately 127, let's round up, miles. Okay. So again, we know the tangent line, we know that it creates a perpendicular angle, and we know a lot of things with right angles. In this case, we knew that the right angle was we use Pythagorean theorem. Okay. Alright, so my last one is I have the circle O is inscribed in triangle ABC. What is the perimeter? So remember, one of our theorems was that when the tangents right here, when it's a tangent right here of the circle, that the two sides are going to be equidistant from the circle. So again, if this is 10 that we have right here, and that is a tangent with O, then this right here would be 10 as well. If this is going to be 8, this side right here is also going to be 8. And again, tangent means that the opposite ones are going to be the same. So if that is 15, then this is going to be 15. So if we're trying to find the perimeter, all we're going to do is add these all together. So it looks like I have 2 10s, plus I have 2 15s, and I have 2 8s that I have right there. So this is going to give me 20 plus 30 plus 16, I get 50, and my final answer is going to be 66. And again, we're talking about perimeter, so it's just going to be labeled, that was terrible, centimeters. Let's fix that right there. Centimeters. 66 centimeters. Alright, cool. Alright, we'll do some more practice problems in class. See you guys soon.